Okay guys, just want to go through the answers to the work there that you submitted yesterday. So question 11, first question is the organ used to pump blood around the body. So the answer here is the heart. Sorry, no. So the heart pumps the blood around the body. Then it says arrows are drawn to show the direction of the blood flow to and from the lungs. Draw similar arrows in the diagram to show the direction of blood flow at A and B. Okay, so basically we know that there's two circulations. There's the circulation of the heart in the lungs, and then there's the circulation from the heart around the body. So we have a double circulation. So here we can see blood flowing out of the heart to the lungs. That's your pulmonary artery into your lungs, and then pulmonary vein bringing blood back. This would be blood coming out of the heart. So there's your arrow there. That'll be the aorta, and there'll be blood coming back in through the vena cava. And then at B, they're saying then the intestines and liver. So remember, the intestines are wrapped with blood vessels. They would take in nutrients and so on, and then some of those toxins that would be there would have to go to the liver to be, I suppose, filtered out. So the arrow goes from the intestines to the liver. Okay, so that's part B. Part C, then it says mark letter G, place the diagram where blood gains oxygen. So the only place it gains oxygen is the lungs. Okay, then letter L on the diagram where the blood loses oxygen. So anything that's using up oxygen. So they have said the head and arms here, should I say? You could put L there as well, because the lower body legs, the muscles would use up oxygen. And lastly, then mark the letter N, a place in the diagram where the blood gains food. So we know that's the intestines. So mark it with N. The body needs both food, as part D, and oxygen for respiration. Describe what happens during respiration and explain why respiration is important for living things. Big thing here is that all living things take in glucose and oxygen. That creates energy. But also the two byproducts are CO2 and O2. Okay? So that is respiration, or aerobic respiration, because oxygen is used up in that. And it's important because if we don't have respiration, then we can't create energy, then the cells can't live. Part E then, name a location in the body where the pulse rate is normally measured. So the wrist or the neck. Part 2, give one reason why Sinead's pulse rate increased after exercise. When you exercise, the muscles and the cells require more energy. So to get more energy, they need more oxygen and glucose, and to get more oxygen and glucose, that's in the blood. So the heart it pumps the blood faster to get to those areas quicker. So that your heart rate increases. And last is in part 3, name one lifestyle choice that could cause a person's pulse rate to increase over time. So lack of exercise, with the answer there. Question 12. So this is interpreting tables of information. So it's important to look at a table and extrapolate the information from it then. So comparing the data, which is the lowest gravity? So when you look at them, the gravity on Venus is 0.9, the gravity on Earth is 1, and the gravity on Mars is 0.4. So that's the lowest one, so obviously enough, Mars is the lowest gravity, 0.4. Part B, two reasons each for why both Mars and Venus, why we could not live on Mars and Venus. So, if we look at them, Venus's temperature is 462 degrees Celsius, so obviously that's way too hot, we won't be able to survive that. And there's no oxygen in Venus's atmosphere, so therefore we wouldn't be able to breathe. So that's the two reasons for Venus. For Mars then, it's too cold, so minus 20 degrees Celsius. And lastly, again, no oxygen in Mars' atmosphere, so therefore we couldn't live there. Now that all the information is taken from the table, and you'll find it in the table. Then it says similarities between Venus and Earth, so there are a few. The gravitational pull of Venus and Earth is similar because they're similarly sized. Venus and Earth have similar diameter. So they're again similarly sized in that regard. So we have the same gravity, same diameter, and both contain nitrogen within their atmospheres. Okay, so I think one of those would probably be enough. And lastly, then D, on which planet would humans have difficulty moving? Okay, so the gravitational pull, if you remember back up here, on Earth is 1. It's a bit less on Venus. They're the same, but on Mars is 0.4. It's like you would be 40%. 60% lighter on Mars, so like you wouldn't be able to walk around, so it'd be very, very difficult to move, so the answer there would be Mars. Question 13 then, they're asking to show the changes of state. So with 10 grams of ice, it's really get your mass balance, get 10 grams of your ice, put it into a beaker, put a Bunsen burner underneath. Make sure all these diagrams are labelled. And all you're doing then is heating it. The ice will turn into liquid water, which is showing melting. So that's the one change of state. And then if you continue on to heat the water, that will eventually turn into steam. And if you put a clock glass or something over to the steam to hit it and condense back into liquid water, that will show evaporation of the steam and actually then shows condensing. Then you could actually take your beaker of water, put it back into the freezer, and you could show freezing if you wished. Then part B shows a heating curve, and it asks you to show there is the freezer. The states of matter in solid, liquid, and gas. So they're tightly packed together, bit of room between them, loads of room between them. Okay, and we should know the properties associated with those. And finally, then, part C, not finally, the points A and B in the heating curve. So if you look at your diagram, A is where it's going from a solid to a liquid. So we call it the latent heat of fusion. So basically, it's the energy going in to change all of the ice into liquid water before the temperature actually starts to increase again. So that point A is just melting. It's where it's changing from a solid to a liquid. If you look at your diagram, then again in part B, it's where the liquid is turning into a gas. Again, this is called the latent heat of vaporization. In other words, that the liquid has to fully turn into steam before the steam starts to heat up again. And basically, all you have to say here is that at that point, it's turning from liquid to a gas, so it's evaporation. Okay. And lastly, then part D, it says about physical changes and chemical changes. Remember, changes of state are just physical changes. It's the same stuff, right? So the atoms are similar. So there are the atoms there. Look, there's water atoms, there's water atoms, there's water atoms. It's just the state that they're in or how they're separated is different. Remember, in a chemical change, a completely new substance is formed. In a physical change, the substance remains the same. So in this regard here, there's no change in mass. So even though like you go from solid, liquid to gas, the mass present remains the same. The number of atoms present remains the same. And the types of atoms present and the way in which they're bonded together remains the same. So it's completely a physical change. The only difference between them is the amount of energy that they have, which allows them to be either solids, liquids, or gases. Okay guys, hope that helped. Take care.